Good morning, everyone. So welcome to the breakout session, the Nexus of Food Safety and Plastics, Navigating Challenges and Opportunities. We've got a great set of speakers for you today and a good conversation on complex challenges. As I said, on Nexus of Food Safety and Plastics, our speakers will examine the emerging scientific and regulatory landscapes surrounding chemical contaminants in food production, design and packaging with a focus on PFAS. We've got three great panelists. We have our very own Cedric Devere, who is our Director of Sustainability at the CGF, Consumer Goods Forum. We also have Felix Cornhill, who is from Systemic, a systems change organisation. And then we have Mark Roberts from Berry CPI, a innovative packaging solutions supplier. And I should have said, I'm Lysander Kesson. I'm Head of Projects from GFSI. So welcome, everyone, and looking forward to the discussions. If I hand over to Cedric first. The clicker's on there.
Hello, everyone. I'm Cedric, and I'm leading the Plastic Waste Coalition of Action of the Consumer Goods Forum. It's one of the 9 initiatives that are within the organization. Then, the Plastic Waste Coalition is a CEO-led initiative that gathers 43 consumer goods retailers and manufacturers on plastic packaging. The goal is really to make actions and also to focus on circularity. Then today, I'm going to speak about what is the connection between recycled plastics and also food safety. Then let's start. I think you are aware of the plastic crisis, but it's always good to remind what is the size of the game. When we are speaking about plastics, every year it's 400 million tons of plastics that are produced globally, huge volumes, and roughly a big part of it, 160 million tons, are coming from single-use plastic packaging. And from these 400 million tons, less than 10% of the plastics that are collected are recycled. It's not a lot. Then meaning that also from this 10%, there is only 30% that is coming from the consumer good industry. Meaning that the consumer good industry has a big role to play in order to work on this crisis. Then what is important, it's also to say that governments are not waiting. They are already from plastic taxes to ban. They are doing a lot of things. And then it's now moving forward for the consumer good industry. It's not optional, it's an obligation. And today, there are 3 main levers in terms of plastic regulations. The first one is really working on how to reduce the usage of plastic. Then there are plastic bans, there are reduction targets, there are also how to move from single-use model to reuse refill. But you have also a second lever, which is better plastic. What does it mean, better plastic? It means that you are designing your packaging in order that if it's collected, it will be well sorted and it will be well recycled. It's a very important thing. And after, it's also how to improve the collection system. Because if there is no collection system, your plastic waste, it can be very well designed for circularity, it's not going to work. Then there are also a lot of regulations playing on, introducing how to improve the collection, then via plastic taxes, via extended producer responsibility, meaning that the consumer good industry is also responsible of the plastic waste that they are putting from the product that they are putting on the market. And all these plastic regulations are really having the same thing in common. It's that they are pushing the usage of recycled plastics for food packaging applications. If you look at, there are a lot of regulations, and I just highlighted 4 of the main regulations worldwide. There is in the European Union what is called the Packaging on Packaging Waste Regulation that has been entering into force in the following weeks, months. It's really, there are a lot of targets, but one of the main targets is really introducing recycled content for foods in contact-sensitive packaging, then also for applications in contact with food. Then there are some recycled content targets. If you look at also in UK, there are the UK taxes, meaning that there are tax on plastic packaging with less than 30% of recycled content. You have in US, at US state level, there are a lot also of push from the states in order to have legislation regarding extended producer responsibility in various states. Last year, it was roughly five states in US that also implemented these regulations. And it creates indirectly a demand on recycled plastics of high quality in order to be suitable to be put in contact with food applications. On the last one, it's a very important one. It's that there are currently negotiations on what is called the UN Treaty on Plastic Waste. There will be a last round of negotiation in August of this year in Switzerland. And the goal is to have a global treaty for plastic waste. And same thing, again, it's going in, what means design for circularity, what needs to be done in order that your packaging could be reused, refilled. But there are a lot of targets in this UN treaty currently under discussions. But same thing, it's also push also the need to have some high quality recycled plastics for food contact applications. What is important to add is that not all plastics are all recycled plastics are suitable for food applications. Usually, I'll summarize this, but I presume Mark is going to share a little more about what does it mean. But usually, you need three conditions in order that the recycled plastics are suitable for food-grade applications. First one, you need to be sure that the source of plastic waste, you can't use anything. You need to be sure that it comes primarily from food packaging to minimize contamination. Same thing, when it goes through a recycling process, you can't use all processes. You need to have an approved recycling process, and usually you have GFSI in the European Union that is approving the process, or it's in US, it's the FDA that is approving this process. Then you need to be sure to have a robust process of decontamination in order that if there are any molecules that are in your plastic waste, it will be cleaned via the recycling process. And same thing, at the end also you need to have the same safety standards as virgin plastic. What does it mean? It means that you need to do all the usual tests that you are doing on your virgin packaging if you want to use it for food contact applications. Then you must comply with the European regulation, with the US regulations, and there are extensive testing. Then a lot of things are, a lot of migration tests are done, etc. A lot of analysis are done on this. Then what is the role of the organization that I'm leading on this topic? It's today, this coalition is really scaling up good initiatives, but in a pre-competitive environment. What does it mean? It means that today we have 43 industries that are working within the coalition. They represent roughly 10% of the global plastic packaging consumption. Then meaning that if there is an alignment, it could be really impactful for the world or for the industry of the plastic packaging world. We are always searching for critical mass of members to develop and implement pre-competitive solutions, because all the 43 companies are going to say, hey, I want to collaborate with my peers, but everyone is having also its own agenda. Then it's very important to find a critical mass in order to be sure that we are aligned on a specific topic. And today, this organization, then the coalition, is working in 5 different pillars. We have the design And I'm going to speak about this, why it's super important if you want to move forward on food safety. Then there is the design. There is also a working group dedicated on reuse refill. How can you switch from single to multi-usage packaging? You have also a working group dedicated on alternative materials, because there is a big push to switch from plastic to paper-based solutions. And after, there is also on EPR, then what is the position of the coalition on this extended producer responsibility? On the last one, on the UN Treaty, how can we support the negotiations by bringing the voice of the industry? We are very well connected with other organizations, such as the Ellen MacArthur Foundation, that is really a leading organization in the field of circularity, and also with WWF and others. Then what we are doing, one of what we developed, it's what is called the Golden Design Rules. It's a set of 9 rules in order to say, hey, if you are doing a plastic packaging, what needs to be done in order that you improve the circularity of your packaging. And it's very important because there is a direct connection between well-designed packaging and after having some recycled plastics of high quality that would be suitable to go for food contact applications. This 9 rules has been developed a few years ago, and today we have roughly, thousands of companies that are at least using one of these rules. It's very important because there are some rules that are connected on chemicals of concerns, what you need to remove. If I'm taking the example of the rule number 2, it's really focusing of removing chemicals of plastic of concerns in order to facilitate the recyclability of the packaging. Same thing, we have some rules also dedicated. If you are doing a PET bottle for beverage applications, what needs to be done also in order to facilitate the collection, the sorting, and the recyclability of the packaging. Then by doing this, you are also improving the collection. And it's very, to share some example, for example, Nestlé removed some problematic labels in order that it facilitate the recycling of the PET bottles. And there are a lot of good examples such as this. And I'm just ending my 10 minutes presentation, and I'm thinking I'm already out of the time. But 3 key messages, I think, very important if you need to keep 3 messages from what I'm saying. It's really regulations on plastics are tightening. Compliance is no longer optional. Then all the industry needs to move now, and otherwise it will be too late. Food safety and recycled content must go hand in hand. And also very important, it's really collaboration. It's key. Whatever the size of the company in the consumer goods space, nobody is big enough in order really to change this plastic crisis. Then it is why the coalition is a very good space in order to work collaboratively and to make a real impact on the plastic packaging world. Thanks. Now, thank you.
Thank you, Cedric. If we hand over to Felix now, and not to worry about time, I think we clawed some time back from my intro. So over to you, Felix. Thank you.
Thank you very much. So hi, I'm Felix. I'm a manager at Systemic, which is a firm dedicated to accelerating the system changes to a net zero and nature positive economy. And we do that by working with pioneer businesses and business coalitions like the Consumer Goods Forum, but also with governments and NGOs across a broad range of topics. And I led the development of a report last year on PFAS in food delivery packaging that we wrote together with Uber Eats, or with funding from Uber Eats. But today I want to expand that a bit with a focus on food packaging more widely and packaging and plastics in particular. I'm sure a lot of you are already familiar with PFAS. I'm going to do a very quick introduction. So PFAS stands for peer and polyfluoroalkyl substances, and the acronym was developed so that I don't have to say that very often. They're a large group of synthetic chemicals that have been commercialized starting in the 1940s and 50s. There's no single accepted global definition, but up here you see a definition that's put forward by the OECD that's quite widely accepted. And it's a very large and diverse group of chemicals. Estimates vary, but the US EPA currently lists almost 15,000 different chemicals that fall under this category. And the one common characteristic that they share is a carbon-fluorine bond, or a number of them, which is one of the strongest bonds known to organic chemistry. And that means it's highly chemically and thermically stable, or these compounds are highly stable. If you want to find out more, I recommend this QR code to a lecture by Professor Ian Mudway, who gives a really great overview of the history, the risks, etc. And so this common chemical structure gives PFAS very useful abilities. They're water, oil, and grease resistant, chemically resistant, thermically stable. They repel water and are weather resistant, reduce friction, and form films. So they're widely used in packaging, in industrial processes, in clothing. Basically, every single one of you is probably having and wearing PFAS somewhere on their body right now. And they're therefore they've become ubiquitous in their use due to these properties. But the characteristics that make PFAS so useful and so attractive to use in lots of contexts also make them hazardous. So PFAS are also known as forever chemicals because this stability leads to them being able to exist in the environment for hundreds or up to 1,000 years, which means they are very persistent in the environment. If we stopped to produce PFAS today, we would still be dealing with PFAS in the environment and in our bodies for generations to come. Secondly, they're mobile, particularly when dissolved in water. So they're in our groundwater, in our drinking water, and also in our air and our soil. So studies have found from samples taken across the world that the concentrations in rainwater of PFAS exceed the levels considered safe for drinking water in Denmark and the US. They're also bioaccumulative, which means that organisms, plants, humans, absorb them, and they also biomagnify, which means algae, plants that take up PFAS that are eaten by other fish, seafood, and then eventually eaten by us. The concentrations of PFAS grow as you move higher up in the food chain. They've also been found to exhibit various toxic characteristics, and here I have to be a bit careful because, of course, there's close to 15,000 PFAS, so they've been studied to varying degrees, but given that they share the same common chemical characteristics, there's increasing evidence that most of them share these characteristics. So PFAS have been found to be toxic for human reproduction and harmful to the development of fetuses. They may cause various cancers in humans, and they're also suspected of interfering with the human endocrine system, so the hormone system. And lastly, they're widespread in the environment. They've been found anywhere from the Antarctic to Marianas Trench, and in hundreds of animal species, as well as in humans. They're basically in the blood of every human living in developed economies, as well as in organs of fetuses. So because of this, these hazardous characteristics, regulation of PFAS has become increasingly common. The landscape is still very much fragmented, so this graph is probably too small to read, but it illustrates the fragmentation of regulation across different markets. But you can see that regulation is becoming more and more common across different markets, and it's also becoming broader. So each color here represents a different type of PFAS or group of PFAS, with the light blue indicating universal bans on PFAS in food packaging. So increasingly, some states, so Denmark and France, as well as 11 US states, have phased out PFAS in all food packaging applications. And another reason, in addition to the hazardous properties for the broadening of these regulations, is that individual bans of individual PFAS of this wider group have led to regrettable substitutions. So On the graphs, two graphs here on the left, you see two of the original and most common, formerly most common PFAS, PFOS and PFOA, which were banned starting in the 2000s. And you see here the concentration of these PFAS in breast milk samples in the US. And you see they are declining, which is what you would expect with a ban. But at the same time, on the right-hand side, you see other types of PFAS, shorter chain PFAS, increasing. And originally, it was thought that these were less problematic, less harmful PFAS, but now the evidence seems to indicate they're more mobile and also very persistent and prevalent in the environment now. So can we live without these PFAS? The European Chemicals Agency is currently evaluating a ban of all PFAS in all applications. And based on that assessment and consultations, they find very clearly that for both paper and plastic packaging and food applications, alternatives are scalable, available, and that is, also matches the assessments of other groups, and also is borne out by the examples of states and jurisdictions that have already phased them out successfully. So it's possible. And so we recommend that firms proactively seek to phase out these substances from their processes based on the rationales that are outlined. But I think it's important for businesses, they can benefit by proactively phasing out PFAS because it allows them to mitigate regulatory, operational, and reputational risks. It also allows them to avoid unpredictable shocks from short-term phase-outs. So some of the restrictions that I outlined on the previous pages came into force with less than 12 months' notice, so very difficult and often costly and disruptive for firms to act upon that and implement that. It also allows firms to then control the pace of transition, avoiding disruption. And lastly, when they carefully, on their own terms, phase out these substances, it allows them to ensure that they are choosing safe, sustainable, and competitive alternatives rather than trying to, in a rush, go to the nearest best alternative. In the report, we also outlined some of the challenges business face, the first amongst which is that they struggle to identify where and why substitution is required. So companies most often don't know where PFAS are in any of their products, and odds are their suppliers also don't know. Because there's such a high diversity, everyone along the supply chain has confidential information, and so you can try to ask your suppliers, but you probably still need to do testing to identify levels of intentionally added PFAS in your substances. And also the understanding within companies varies. There's, of course, experts, but trying to get this issue escalated and making sure that you get buy-in across a company to take this step proactively can be quite challenging. The second challenge is then selecting the appropriate PFAS-free alternatives, and there it's really important to consider all of the possible solutions, including designing them out, shifting to reusable formats, like Cedric mentioned, and not just considering like-for-like substitutions. But that's definitely a process that requires careful consideration to make sure you not only meet functional and economic performance criteria, but also ensure sustainability, end-of-life impacts, and toxicity, of course. And then lastly, operationalizing that shift can be quite challenging in practice as well. So in conclusion, it's possible for firms to phase out PFAS from food packaging. It's also advisable for them to do so proactively and to manage the transition on their own terms. And if you'd like to find out more, we have lots of helpful frameworks, tools, considerations for this transition in the report. And if you'd like to find out more or continue this as a conversation, feel free to reach out. Thank you.
That's perfect, right on time. Thank you. If I hand over to Mark.
Thanks very much.
Thanks, Mark.
Thank you. Right. Okay, so what I'd like to talk a bit about today is the journey that we've been on in terms of trying to get to a contact-sensitive recycled polypropylene, so a recycled polypropylene for